Good morning, my dear students. My name is Sharma, working as physics lecturer in one of the reputed institution. Today our concept is about Bernoullis theorem. Okay, so based on this Bernoullis theorem, you will be definitely given one question in any competitive exam like NEET, Mains, EAMCET, etc. Okay, so before going to know about this Bernoullis theorem, let us take some examples. Okay, so this lifting up of an aeroplane. Okay, and about windstorm. You know, in windstorms, the roof of the huts are lifted up in air, and you know, this sprayer, perfume sprayers. Okay, and about heart attack. So these are all related to Bernoullis principle, Bernoullis theorem. Okay, so now our concept is about Bernoullis theorem. So once you know this principle, you can apply it in many. Now about Bernoullis theorem. So according to Bernoullis, a fluid which is incompressible, non-viscous and irrotational. Okay, incompressible means everywhere density remains same. Irrotational means without rotating. Non-viscous, no sticky nature. Such fluid follows Bernoullis principle. So according to Bernoullis, sum of potential, pressure, kinetic at any point of fluid flow remains constant. Okay, so in order to verify about Bernoullis theorem, let us consider one non-uniform cross-sectional pipe. Okay, so area of cross-section at this end is A1, other end A2. Pressure at this end P1, other end P2. So this pipe is at a height H1 from one end, H2 from other end. Okay, velocity at this end V1, the other end V2. Okay, now you know, due to difference of potential or due to difference of pressure, fluid flows from one end to other end. Okay, so now about potential variation, potential energy difference. You know, mgh1 difference mgh2. So mgh1 is a potential energy of the fluid at one end, the other end mgh2. So you know, m is the mass of the fluid that entering, same mass is leaving from the other end, that is if it follows continuity, right? Now about pressure energy difference. So you know, pressure taken as force by area, na? Force by area, right? So work done is equal to, you know, pressure into area into displacement. Nothing but you can say velocity into time. So pressure at one end, pressure energy at one end, you know, P1, A1, V1, T. Now the other end, P2, A2, V2, T. So you know, it is the difference of pressure energy, and you know, this is the difference of potential energy. You know, total work done is due to, you know, variation of pressure, and you also know variation of potential. Therefore, what is the total work done in this process? You know, mgh1 minus mgh2. You know, it is nothing but, you know, negative work, lifting anything from ground, right? Plus P1, A1, V1, T, right? Minus P2, A2, V2, T, right? So you know, work done is equal to mgh1 plus P1, A1, V1, T, right? Minus mgh2, right? Minus P2, A2, V2, 2. So you know, it is a difference of potential variation and also pressure variation, right? Now, according to dynamics, work done by a fluid is always equal to change in kinetic energy. In work energy theorem, remember, work done is always equal to change in kinetic energy, right? So work done is equal to half m v2 square minus half m v1 square. No, that is according to work energy theorem. Okay, so these two are equal now. So this is by fluid mechanics and this is by dynamics. So both are equated. Okay, now both are equated. So both are equated. That is, mgh1, right, plus p1a1 v1t, right, minus mgh2 minus p2a2 v2t equal to change in kinetic energy. So final kinetic energy minus initial kinetic energy, right? So you can bring all one first point kinetic energy to other end, right? So mg h1, right, p1 a1 v1t plus half m v1 square is equal to, you can take other end now, that is half m v2 square plus p2 a2 v2t plus m g h2. That means sum of potential, pressure, kinetic at first point is equal to sum of kinetic, pressure energy, potential energy at other point. Nothing but it is Bernoullis principle. Sum of kinetic, potential, pressure at any point remains constant, right? So you can take m common now, cancel. Then g h plus p a v t, okay, plus v square by 2 is also constant now. So that is by taking m common. So if you take m common in the denominator, you get m, right? So p a v t by m plus v square by 2 equal to constant. So mass can be taken as density into volume, no? So GH plus PaVT by mass taken as density into volume. Volume can also be taken as area of cross section into displacement, right? Plus v square by 2 constant. Okay, so you can cancel this a also. And displacement can also be taken as velocity into time now, because you see velocity is displacement by time, then displacement is Vt, right? So this can also be taken as Vt, right? So this is also cancelled. Therefore, so what is the general equation? GH plus P by rho, right, plus V square by 2 is always constant. Okay, now this we are going to apply in case of lifting up of an aeroplane. Okay. Now, let us suppose there is an aeroplane moving horizontally in a fluid, nothing but air, right? So when it is moving in air, so these wings plays very important role while it is moving horizontally in air. So due to this wings, the air divided into two layers, okay, two layers of different pressure, different velocity. Okay, so pressure at the bottom, let us assume P1, top P2. Velocity V1, V2. Okay, so when the aeroplane is moving horizontally in air, so the air layers are divided into two. So top pressure P2, velocity V2, bottom P1, V1. So pressure at the bottom will be more and top less. Okay, so velocity less at the bottom, more on the top. Okay, so now we apply this to Bernoullis principle. Okay, so there is no height variation now because it's moving horizontally, right? So that is why there is no potential variation, only pressure and velocity, right? So that is why bottom, so take P1 by rho. So where rho is density of air plus V1 square by 2. Okay, bottom I am taking. Top, P2 by rho plus V2 square by 2. So it is moving horizontally. Remember, when a fluid is flowing through a horizontal pipe, no potential variation. Okay, now you can take this to one side, right? P1 minus P2, right? By rho you can take, which is equal to V2 square by 2 minus V1 square by 2. Okay, or else you can write difference of pressure is equal to rho into half of V2 square minus V1 square. So difference of pressure in case of an aeroplane moving horizontally, the difference of pressure is rho into half V2 square minus V1 square. Suppose you want to know the force required to lift up this aeroplane. Pressure can be further changed into force by area na. So force or thrust by area is equal to rho into half of V2 square minus V1 square, or force required. Okay, force required to lift up an aeroplane, right? Force or thrust is equal to half into rho into A. So A is nothing but area of this wing. No? So V2 square minus V1 square. So remember, force required to lift up an aeroplane is given as half rho A of V2 square minus V1 square. Okay? So based upon this model also, you can expect one problem in the competitive exam. Now, next about Bernoullis theorem. Okay? Now Bernoullis principle we are applying to Bernoullis theorem. About Bernoullis theorem. So what is Bernoullis theorem? When a fluid allowed to fall through certain height velocity gained is equal to velocity gained by a freely falling body. For example, if a freely falling body allowed to fall through a height h, then velocity gained is root 2g h. Similarly, when a fluid allowed to fall through a height h, it will also gain same velocity. Okay, so in order to verify this, let us consider one tank of total height h, capital H. Okay, so there is one tap connected at a height small h from top. Okay, so the remaining height will become h minus h. Okay, so total height h. Tap is at height h. From ground h minus h. Okay. Now apply Bernoullis principle to these 2 points. So you know sum of pressure energy, right? So pressure plus half rho V1 square plus rho G H1. No, potential head, pressure head, kinetic head is always constant now at this point is equal to the other end P2 plus half rho V2 square plus rho G H2. Right? Now, pressure at this point is almost equal to this because this height is very small value now, so that is why they are cancelled. Okay, now half rho V1 square plus rho G H1 equal to half rho V2 square plus rho G H2. Rho common now, so that also you can cancel. Now V1 square by 2 plus G H1 equal to half V2 square plus GH2. Okay, now equation of continuity. So whenever flow is continuous, then this product AV product is always constant now. So that is why A1 V1 equal to A2 V2. So A1 means area of cross section of the tank. A2 area cross section of tap. So this is having small value than tank area of cross section, right? So you can write V1 as A2 by A1 now into V2. So this ratio is very small because a small value by a large value, so almost equal to 0 we can say. So this part is also neglected, right? So now about H1. So initial height is H now. So I can take G capital H equal to half V2 square plus G H2 means this height now, the tap is at height H minus H, right? So you can take to other side now. So GH minus GH, okay, plus small gh, right, equal to V2 square by 2 now. So cancel. So you get V2 is root 2g h. So what do you notice when you allow to fall a solid from height h, it will gain velocity equal to under root 2g h. Same as the fluid allowed to fall through a height h. That is Bernoullis theorem. That is velocity gained by a freely falling body when it allowed to fall through a height h is same as fluid. Okay, nothing but under root 2g h. Now based on this concept also you will be given definitely one problem. Suppose you have given a question that is where we supposed to connect the tap so that it will cover maximum distance? That is your question. So what is your given question? Now that is you want to know the position of the tap, so that distance must be covered by maximum. Okay. So this is the tank. Suppose tap is connected at a height h. You know total height h. Okay. So now you want to know the position of the tap so that this distance should become maximum. So you must have studied in kinematics, projectiles. Range is equal to always horizontal component of velocity into time of flight, right? So here velocity gained. So just now we completed that derivation part, that is under root 2gh now. So that is why it is under root 2gh. Time of descent. It is allowed to fall through a height h minus h. So that is why time of descent is under root 2h by g now. So in place of h minus h by g. Right? So this root g cancelled. Okay? So range is equal to 2 into root over h of h minus h. H of h minus h. Squaring on both sides. Okay? Now you differentiate on both the sides with respect to height. Okay? So you are differentiating, okay, with respect to height, because you want to find the position at which the tap is to be connected. So dr into dr by dh na equal to 4 into h na. So h differential value is 1 na, minus 4h square, right? So h square differential value is 2h. No? So if this range is maximum, this differential value must be 0. No, because you want to know the point at which tap is to be connected so that this distance should become maximum. Okay, if this is 0, this whole thing is 0, right? Then 4h minus 8h equal to 0 now, or else 4h equal to 8h cancelled, right? So h is h by 2. That means the tap must be connected exactly at half of the height of this tank, so that it will cover maximum range. Okay? Now, so in the beginning, I said due to Bernoullis principle, we can know about heart attack. That is the inner pressure and outer pressure variation only the fluid flows, right? So due to variation of pressure only fluid flows. So in case of heart, you all know that heart pumps blood to various parts of the body now. So pressure variation inside and outside is also very, very important. Whenever the inner pressure in the heart increases, then forcibly the blood is pumped to various parts of the body, which leads to heart attack. And about a sprayer, in case of sprayer, so whenever you press this knob now, so the perfume will be sprayed. That is the moment when you are pressing, so it will create more pressure at the bottom, less pressure at the top. So due to this variation of pressure, the fluid is flowing from top to bottom. It is also nothing but Bernoullis principle. Okay, So if you like this video, please subscribe, like and share and forward to your friends also. Thank you. Thank you.